Alright guys, so we're starting a new unit which is conics. We're going to start with parabolas, which you guys remember. It's a bunch of reading here at the beginning. That you'll remember parabolas from graphing quadratic functions, but we're looking at it into a different form in this unit. Alright, by definition, a parabola is a set of points that are equidistant, very important, from both the directrix, a fixed straight line, and the focus, which is a fixed point, which will fall on the axis of symmetry. Alright, since we're not looking at parabolas as functions, either the x or y coordinate can be squared, and the parabola can open up, down, left, or right. I really don't have time to derive what happens with you guys like I wanted to, but here's an example. So this segment here is equal to this segment here, or congruent. That's what those tick marks mean. Alright, so main things we'll be using when the vertex is 0, 0, we are in this form right here. Alright, one thing you should remember a little bit is that this 1 over 4p you've never seen before, well, that's your a from back when we dealt with parabolas before. So a is equal to 1 over 4p. That's going to be important to be able to deal with later. Alright. When it's y equals, we open up or down. X equals, we open up right or left. Okay. If 1 over 4p is negative, then we're opening up down. And y equals, or left, and x equals. That'll be important to think about in this unit. If 1 over 4p is positive, then we are opening up, and y equals, or, whoops, not down, right. And x equals. Okay, I do have to move a little quick because of time constraints. So find the vertex, direction of opening, axis of symmetry for each parabola. Alright, so in this case, vertex is here, so the vertex is 4, 6. Okay. Opening, obviously you can see it as being down, and the axis of symmetry, remember it cuts the parabola in half, so it does that. It's a vertical line going through 4, so it's x equals 4. Alright, when it opens up left or right, there's my vertex of negative 1, 6. Obviously, you can see that it is opening left. Don't know why I was putting a parenthesis there. Opening left. And the axis of symmetry, again, cuts it in half, so it does this. Horizontal line going through 6, so it's y equals 6. Alright, now given equations, we want to do the same thing. So this right here, in vertex form, it is really this. So my vertex, pretty easy, is 0, 0. Opening, y equals means I'm either going up or down. Since that's positive, it means that I'm opening up. And my axis of symmetry is going to be x equals 0. So remember, so in this case it's opening up, right, with a vertex like that. So it goes right through x equals 0. Alright. Alright, so x equals 5, y minus 0 squared plus 0. So again, my vertex in this case is at the point 0, 0. My opening, now I'm either opening up right or left. That's positive, so I'm opening up right. Okay. And my axis of symmetry now is going to be y equals 0. Because again, I'm opening up right, which means now my axis of symmetry is the x-axis and not the y-axis. So for this one, x equals 7, y minus 0 squared plus 7. Okay, so remember, now I have a number here. This is h and that's k. So my vertex is 7, 0 in this instance. Opening is like the last one, it's right. And my axis of symmetry looks at the y value because it's opening up right, so it's y equals 0. Alright, now for the fun ones. Finding the focus and the directrix. So we have to start by finding the vertex. Well, the vertex in this case is at 0, 0. Like that first one we had up there. Okay? Alright, so now what we have to do, remember this spot right here is 1 over 4p. Okay, so negative 3 is equal to 1 over 4p. So when I multiply by 4p, I get that 1 equals negative 12p, which means p is equal to negative 1 over 12. This is my distance from, or this is how far the vertex is from the focus and the directrix. Okay, so this parabola is opening up left because it's x equals with a negative 1 over 4p. So my focus is here, my directrix runs here, and that's a terrible line, but you guys will be okay. So from 0, 0, really from the x-coordinate, I go left to get to the focus and right to get to the directrix. Okay? So really this negative doesn't matter. Okay? So for my focus, from 0, I have to go left, so I'm going to subtract 1/12 from that, which means my focus is at negative 1/12, 0. Okay, my directrix, which is a line, I have to go right from that 0. So I'm going to add 1/12, which gives me, in this instance, that x equals 1/12. Okay, so this one's a little different. So y equals, with a positive 1 over 4p, is opening up. Okay, so my focus is here, my directrix runs here like this. Okay, so vertex is at 0, 0. Now 2 is equal to 1 over 4p. Do the math, that's 8p. So p is equal to 1 over 8, right? So up to get to my focus, so that means I have to add to the 0. So my focus, 0 plus 1/8, is equal to 1/8, which I want to talk about this. So remember, this is going to be on the y-axis, so that means it's going to be the coordinate 0, 1/8. Okay, my directrix, which is now a horizontal line, is going to be y equals, right? So it's going to be 0 minus 1/8, which is negative 1/8, or y equals negative 1/8. You guys will have to slow down at this point. Alright, so continuing, so y equals positive, so this thing's going to open up with a vertex that would be at, what, 9, 5? So it's going to be like here and opening up like this. Okay? So vertex is at 9, 5. So in this case, 1/4 is equal to 1 over 4p. That's kind of nice because these are the same. To keep the 4, that means p really must be equal to what? Must be equal to 1. Okay, so remember my axis of symmetry runs like this. The focus is going to be here. The directrix runs like this. Okay, so I'm going to be dealing up and down, so I'm dealing with this 5. Okay, so my focus is going to be at 5 plus 1, or 6, or the value 9, 6. My directrix in this case will be 5 minus 1, or 4, or y equals 4. Okay, so if you're confused, come to tutoring. We will talk about it and we will work through it. See you guys later.